Hello classes, this is Mr. McAllen, and we're going to work on day 18 of our flipped classroom, Unit 5, and what we're going to be going over is the law of signs. And I just want to highlight that this will not be including what's called the ambiguous case. So what we're going to do first is um, what an oblique triangle is as opposed to a right triangle. We're going to remember some geometry terms. We're going to then talk about the law of signs and when it should be used. And then we have this little trick for finding the area of oblique triangles. So here we go. We're going to just have a little review. Here we have a right triangle, and we'd like you to find what W would be. So I'm going to pause the video right now, and you should pause it as well. And what I want you to do is I want you to figure out what W should be for using normal right triangle trig. Okay, and we're back, and hopefully you realize that this was a cosine ratio. Remember, this is review. We've done this lots and lots. In fact, we just had our test today, and this should be an easy problem for you. So hopefully you found W to be 7.9. Now, what we're going to work on is what happens if the triangle is no longer right. That means we don't have a 90-degree angle. It's called an oblique triangle. So when we're going to work with oblique triangles, you have to figure out what type of triangles you've been given and what the information is. And remember, in geometry, you had a bunch of different ways to classify what your given information was. We had things like angle, side, angle. So if you looked at a triangle and you had one angle, another angle, and a side, as you went around the triangle, you would call this situation angle, angle, side. This setup right here, it is angle, angle, side, because as you progress through the triangle, you see you have an angle given, another angle given, and a side given. So on the next one, it would be called angle, side, angle. So what I want you to do is I want you to pause your video, and I want you to tell me or write down what you think the third one is and the fourth one is, and this fifth one. Okay, so pause the video and try it out, and then when you come back, I'll have them written down next to it. Okay, so we're back, and on 3, you notice we have side, and then we go to the next side, we have side, and then we have angle. Now, some people say, well, how do I know it's not angle, side, then side? Well, if you start on the side, and you go to the next thing that's available, we have the second side, and we have the third angle. In the next one, it was angle, side, angle. In the last one, it's side, side, side. So hopefully this helps refresh your memory on some ways that we classify triangles with given information. Now, using the law of signs, it can only be used safely if you're given angle, side, angle, or if you're given angle, angle, side. Basically, if you're given 2 angles and only 1 side, the law of signs can be used safely. Now, it says here, law of signs can be used cautiously. This is referring to the ambiguous case. And the word ambiguous means that there can be more than one answer. The answer is not so clean cut. So when you get a case where you have side, side, angle, this is a situation for using law of signs where you have to use it cautiously. And this video is not about using a law of signs cautiously. It's about using it when you're given angle, side, angle, or angle, angle, side. So we're going to jump into our first example. And in the first example, I'm going to show you what the law of signs is. But first, let's come up with a picture of what example 1 is actually saying. Example 1 says that in triangle, I'm just going to make a generic triangle ABC. You notice I've not really worried about it being right because it's ambiguous. The triangle can have, an ambiguous triangle does not have a 90-degree angle in it. So I'm going to label angle A to be 43 degrees. I'm going to, let me see if I can enlarge that triangle so we can see it better. Okay. I'm going to, well, I guess that's not any better, but I'm going to make angle B 57 degrees And I can find in any time when we're working with angle, side angle, or angle, angle, side, we can always find the third angle. So I expect you to find the third angle. Whenever you're using law of sines, find that missing angle first. So, and then we want to fish label this. So side A is 4.5. The missing sides that we're going to be looking for is going to be side C and side B. So let's first find angle C. So what I want you to do is I'm going to pause the video and I want you to calculate with your calculators angle C and then replay the video. Okay, well, we found that when we add up the other two angles and we take them away from 180, that we get an angle of 80 degrees for angle C. So I'm going to just write in red, angle C is 180. So now let me write down the law of sines. The law of sines is just a ratio between the side of a triangle and the sine ratio of its angle. Notice A divided by the sine of A is equal to side B over the sine of angle B, which is equal to side C over the sine of angle C. So we can use this ratio carefully to find what side B would be. So this is a way I would approach doing it. Whatever you have a complete pair for example, right now we have a complete pair for side A and angle A. You always want to use that ratio. So for example, we're going to try to solve for side B. So what I'm going to do is I'm going to write down A over the sine of angle A, because I have side A and I have angle A, and I'm going to set that equal to side B over the sine of angle B. Now, I have angle B. I have all three things except I don't have side B, but using ratios and cross multiplication, I can find it. So what I'm going to do is I'm going to take side A, which is 4.5, and in blue will be all of my given information. So a 4.5 over the sine of angle A, which is 43 degrees, equals unknown side B, that's going to be red, over the sine of angle B, which is 57. I cross multiply, so I get B is equal to 4.5 times the sine of 57 degrees over the sine of 43. It's just that simple. Now, you're going to take your calculator and you're going to calculate that. So I don't have my on-screen calculator working. Oh, wait, maybe it's going to work this time. And I'm going to calculate this, and then I'm going to come back and tell you what the answer is. What I want you to do is, while you calculate that answer, is I also want you to try to solve for side C using the ratio. Notice how I'm using A over sine of angle A, and you're going to set that equal to, for side C, you're going to say C over the sine of angle C. So I want you to try that. I'm going to pause the video. I'm going to come back and tell you what side B is, and then I want you to try to find what side C would be also. Okay, I'm back, and I think I might have given you too much to do in that last recommendation, but we found side B by cross multiplying using our calculator to be 5.53. Now we're going to go and we're going to write in, again, we use 4.5 for side A. For sine of angle A, it's going to be the sine of angle A, again, was 43, but this time when we try to find C, we're going to use the sine of what angle C is. Angle C is 80. So we're going to use that. We cross multiply 4.5 times the sine of 80. We just cross multiply that up to the top, just like we were doing with normal ratios, all over the sine of 43 degrees. And if you put that into your calculator correctly, you should get the correct answer. I'm going to save you time on the video and do it. And then when I replay the video, I'll let you know the answer. Okay, so I have 4.5 sine of 80 divided by the sine of 43 to be 6.5. Now let me just make sure that makes sense. I have C to be 6.5. I'm going to just highlight that. I have B to be 5.5. I'm going to highlight that just because that's information that I found, and let's make sure that makes sense. So if you notice our given information, which was in blue, we had 43 degrees, gave me 4.5 opposite side. Now, as the angle gets bigger, the side opposite should get bigger. So notice we have a 57-degree angle. This is slightly larger than what the 4.5 was, and then across from 80 is our largest side with 6.5. So my answers make sense, but don't check this using Pythagorean theorem because it's not a right triangle. Now what I want you to do is, for example, 2, I want you to try this one on your own. First, let's have you set it up, and let's see if you can set this triangle up the right way. The given information is angle B is 38, side B is 24, and angle C is 21. Let's see you draw the triangle and figure out what you have. Okay, so we're back, and notice I found the triangle drawing tool, so I drew a much nicer triangle. Label my triangle ABC. It's oblique. Why? Because there's no right angle in it. And notice I labeled my missing sides and my my angles, and all the information was given. In this case, I have angle, angle, side given to me. So because I have angle, angle, side, I can use law of sines. So let's find that missing angle A. So angle A is equal to, if you take 180 degrees and you subtract from it the 21 and the 38, you should get for angle A, well, let's see, 180. I'm using my calculator if you can hear me hitting the buttons. 21 minus 38, and that's 121 degrees. So obviously this picture is not drawn to scale. Now, we want to use the law of sines. A over the sine of angle A equals B, side B over the sine of angle B equals side C over the sine of angle C. We have to find the pair that exists for both the side and the angle, and that is the B side and the B angle. So when we want to find angle A, or not angle A, I apologize, side A, we're going to use A over the sine of A equals B over the sine of B, because we have side B and angle B both given. So I'm going to just write them out real quick. So A over the sine of 121 degrees equals side B, 24 over the sine of 38, which is angle B. Again, we cross multiply, and A is equal to 24 sine of 121 degrees. Remember, this whole quantity gets cross multiplied up into this position here. So that's why it's in the numerator, and then divided by the sine of 38. So A would equal, I'm going to pause the video just so I can calculate. Okay, so we cross multiply and we use our calculator and we get A is equal to 33.4. So I'm just going to write that up in red. And now what I want you to do while the video pauses is I want you to figure out what side C is. So remember, it's a lowercase c, so you're going to use your calculators and this diagram to help you do that, and the correct trig ratios. So I'll pause the video, and then when you come back, we'll share the answer. Okay, so we're back, and I'm going to zoom out so you can see the triangle that we used. And remember, we were looking for side C. So side C said we're going to use the ratio B over the sine of angle B, which we plugged in. We had side C that we were looking for over sine of 21. You cross multiply that sine of 21 up to the numerator of the other side, and then you have a nice easy trig ratio or cross multiplication to solve. And notice I got an answer of 13.97, but since we're only holding the one decimal place, we round up to 14.0. Hopefully this video has helped you understand how to find missing sides of an oblique triangle using the law of sines. Remember to only use it when you're given two angles and a side. In the next video that I'm going to have you watch, it's a short little video on how to find the area of an oblique triangle. So make sure you watch that to complete your homework.